All right, so this is the naming review packet. So make sure you have your reference tables out. We're going to need periodic table, and we're going to need table E for the polyatomics, and you might also need table S to help with element names. So the first sheet has to do with binary compounds. So some review. A binary compound has two different elements that are chemically combined. When you're writing names, the first element name is unchanged. The second will end. You'll change the ending to IDE. When you're writing the formulas, you put down your elements, you put down your charges. By charges, I mean oxidation states, either plus or minus. If your overall charge is not neutral, we're going to crisscross. So that means top left to bottom right, top right to bottom left. And then those become subscripts. We will not write ones, and we will not keep anything negative because now they represent whole numbers of atoms. Directions. If given the formula, write the name. If given the name, write the formula. All right, so the first thing we're going to need is a periodic table for charges. And again, if you don't know where they're located or what a name is, table S. So lithium is a +1, fluorine is a -1. I know because those are both going to equal 0. My final formula is capital L, lowercase I, capital F. It's very important that your handwriting is neat. Things are capitalized when they should be and lowercase when they should be. Sodium oxide. Sodium is Na+1. Oxygen is O -2. So that does not equal 0. So we're going to have to crisscross Na2. So this comes down here. But we don't include negatives. And then the O will not have a 1 written there. We just write the O. It's implied. Potassium nitride. Potassium nitride means nitrogen. That's N-3. So we crisscross because it's not neutral. K3N. Rubidium carbide. Rubidium is Rb+1. Carbide is carbon. It has to be -4. Even though there are many charges, we need the top one and it's negative. So crisscross, you get Rb4, capital C. Cesium chloride. Cs+1, Cl -1. That's neutral. CsCl. Francium sulfide. It's capital F, lowercase r. It's +1. Sulfide is -2. Again, that's not neutral, so we crisscross Fr2s. Beryllium phosphide. Be+2. Sulfur is, that is phosphide. P-3. Again, not neutral, so we have Be3, P2. Magnesium, Mg+2. Silicide, silicon -4. Okay, so when you crisscross this, you're going to get Mg4Si2. And that's going to look a little maybe odd, because see how we can simplify this down, a 2 and a 4. So we can make that Mg2Si. And so let's be clear on that. This is like that. Calcium is Ca+2. Bromide, Br-1. So we have CaBr2. Finally, strontium is Sr+2. And then selenium is Se-2. So that's neutral, so we have just SrSe. Notice, final formulas do not include any charges. So you shouldn't have any charges in your final formula. Let's just do a different color here. All right, now we're going to write names. The first element name stays the same. So this is barium. If you're not sure, use table S. As is arsenic. We make that arsenide, ending with IDE. Scandium. And then iodine becomes iodide. Yttrium, that's Y, becomes fluorine is fluoride. Make sure you spell it UO. Lanthanum. And then oxygen becomes oxide. Ag is silver. And this is bromide. W is tungsten. Iodine again becomes iodide. We have zinc. chloride, aluminum. By the way, if I'm going too fast, make sure you're looking at reference table S for names. Sulfur becomes sulfide. Cadmium, selenide, that's selenium, selenide. And then finally, gallium, Te is tellurium, so that would be telluride. So those are the binary compounds. So probably the easiest step. Next page, we have ternary compounds, which is where we have a polyatomic ion on table E. And remember, we wrote in our reference tables that these were etched in stone, meaning you never change them. Okay, so don't change the name, don't change the formula ever. So, and here it is again, never change the names. If the polyatomic is what starts your formula, then, and the ending is an element, the ending would end with IDE. And the thing about polyatomics is if there's more than one group, you got to put it in parentheses. All right, so I am going to go quickly, but you need to use table E if necessary. NH4 is ammonium. Chloride is regular old element. So since that's neutral, we're just going to do NH4Cl. And we do not need parentheses because I didn't bring anything down. So there's no need for that. Magnesium cyanide. Magnesium is Mg+2. Cyanide is Cn-1. So that is not neutral. So it becomes Mg. Now, if you notice, if I do that, only the N would be doubled. And I need the Cn to be doubled. So that's why we need parentheses. Lithium is +1. Carbonate, CO3 -2. So that's not neutral. So we'll have Li2CO3. No parentheses. Aluminum hydrogen carbonate. Aluminum is a +3. Hydrogen carbonate is HCO3 -1. Even though it sounds kind of weird. And so that crisscrosses to Al, nothing. The whole thing, HCO3 in parentheses, and there's the 3 outside. It's a different 3 than the 3 as part of the polyatomic. Barium is Ba+2. Oxalate is C2O4 -2. So look, that doesn't need any crisscross. Potassium is K+1. Hypochlorite is ClO -1. So once again, no crisscross, everything's good. Calcium is Ca+2. Chlorite, ClO2 -1. So that's not neutral. So Ca would have a 1 crisscross down, which we don't write. ClO2, that whole thing in parentheses, 2 outside. Scandium, Sc+3. Chlorate, be careful, a lot of these sound really similar, so you really have to look. So that's not neutral, Sc, the whole thing, 3 outside. And then we have zinc perchlorate, zinc +2. Perchlorate is ClO4 -1. So we're going to have ZnClO4, all in parentheses with a 2 outside. Finally, we have sodium chromate. So sodium is Na+1. Chromate is CrO4 -2. So that's not neutral. Crisscross the 2 down, CrO4. Okay, no parentheses. Okay, now we're going to take the names and be writing names, taking the formulas, writing names. Okay, so Be is beryllium. And C2O7 is called dichromate. You're using table E. You're copying it right down. That is a typo. Uh-oh, I gotta change that. So it should be ZnMnO4 and not a 4. Oh, hold on a second. I think I found a typo. Oh no, that is not Zn. I meant that to be Zr. That's why. All right, well, I just fixed that. That's, okay. So ZnMnO4, make that change, and then this is going to be zinc permanganate. I got to make a note of that right here. All right, next one, francium nitrate. This is tungsten hydroxide. I'm just using table E. Silver phosphate. Yttrium. And by the way, if you don't know how to spell these elements, go to table S. And that is thiocyanate. Scandium. Sulfite. Not sulfate. Sulfate's the next one. Indium sulfate. Gallium. Hydrogen sulfate. And lanthanum thiosulfate. All right. Let's move on to the stock system. So the stock system is when you have Roman numerals. Roman numerals are needed when you have more than one positive oxidation state. The top part I think is easy. If you see titanium Roman numeral 2, that means that is the charge of titanium. And because titanium has a whole bunch of them, I'm just telling you what the answer is. So titanium Roman numeral 2 means titanium plus 2. Iodide, just like normal, is I minus 1. And then you just do what we've been doing. We crisscross. Ti, I, 2. Vanadium Roman numeral 3 means V plus 3. Oxide, O minus 2. V2O3. Chromium Vi, that would be chromium 6, and it's got to be plus 6. Bromine is minus 1, so CrBr6. Manganese plus 7, and then this is hydroxide, which is minus 1. So we're going to have Mn parentheses OH taken 7 times. Iron is going to be plus 3. Sulfide is a regular old element, minus 2. So we get Fe2S3. Cobalt plus 3. Fluoride element, COF3. Nickel is going to be plus 2. Phosphide, that's a minus 3. So we have Ni3P2. Copper 2 sulfate plus 2. SO4 minus 2, CuSO4. It all cancels out. No need for parentheses. Au plus 3. Permanganate is MnO4 minus 1. Crisscross Au3 MnO4. Are you all set? Okay, the next one is niobium. Thank you. Niobium 5. Nb plus 5. And nitride, is N3. So we're going to crisscross NB3N5. PB, okay, yeah, now we're going to go to the next. So we have lead, and this is going to be carbide. So then the question is, okay, how do we figure out if we need Roman numerals or not? So since we have lead does have 2 different choices. So we're going to have to figure out what is the charge. So if you've got if you've got subscript, you can crisscross them back. So lead, this is actually a really tricky one. Lead would have a plus 1 in this case. Lead plus 1 and C minus 2. And then you go to periodic table and you say, wait a second. Lead doesn't have a plus 1. Lead has a plus 2. So if you go to the periodic table and see that that's not available, you'll have to say, okay, so it must be a simplified form. That's the same. This is actually a really tricky one. That was mean of me to put this on here. Okay, PET is platinum and iodine. So our 2 choices for platinum would be, where are you? Plus 2 and plus 4. Crisscross your charges back. It would be a 2. This is iridium. And this is oxide. So iridium, the choices are plus 3 and plus 4. You can see we're going to use that 3. I'll bring bring that away. We go back to 3. Then we're going to have osmium phosphide. And so osmium, we're going to bring, well, let's see, no subscript. So if P is -3, osmium has to be a +3. So 1, 2, 3. Re is rhenium, nitrate. So then we say, okay, +4, IV. Thallium, carbonate. So thallium could either be +1 or +3. So this is a +3. And I know that because the 3 will go back up. This is niobium chlorate. And the 3 should go back. And so you'll have niobium 3. This is titanium. And this is cyanide. The 2 will go back, and so titanium should be a +2, Roman numeral 2. This is iron. This is phosphide. Phosphorus is an ion. Crisscross the charges back, and you get iron 2. Technetium, and NO2 is nitrite. Crisscross your charges back, and you get 7, which is VII. All right, the last one of these, we have hydrates, which is you need the names. So we have, let's see, mono is 1, di, tri, tetra, 1, 2, 3, 4. Penta is 5, hexa is 6, hepta is 7, octa is 8, nona is 9, and deca is 10. We're not going to deal with anything higher than that. You will have to know those terms. All right. So calcium chloride, Ca +2, Cl -1. So we get CaCl2. And then dihydrate would be 2H2O. Zinc sulfate is Zn +2, SO4 -2. So that cancels. So ZnSO4. The dot. Hepta would mean 7, H2O. Sorry, it's messy. Copper, Roman numeral 2. Sulfate is Cu +2, SO4 -2, so CuSO4. Pentahydrate, 5H2O. That's this one. Iron, Roman numeral 3. Phosphate is PO4 -3, so that's FePO4. Tetrahydrate is 4H2O. Cobalt, Roman numeral 2, chloride, Cl -1, so CoCl2, hexahydrate is 6H2O. Sodium carbonate, Na+1, carbonate is CO3 -2, so Na2CO3, and a decahydrate is 10H2O. Magnesium is Mg+2, sulfate is SO4 -2, so that's MgSO4. And this is a heptahydrate, 7. Lithium is Li+1. Acetate, C2H3O2 -1, so that cancels. LiC2H3O2, 3H2O. I'm getting messy. You don't do that. Barium +2, hydroxide -1, so BaOH in parentheses taken twice, 8H2O. Ammonium is NH4 +1, oxalate, C2O4 -2, so goodness, that's NH4 taken twice, C2O4.H2O. Could you write 1H2O? Yes, but you usually don't. All right, now names. This is tin and this is chloride. Tin has multiple oxidation states, so crisscross it back. It's tin 2 chloride dihydrate. This is lead. Oh my goodness. Lead acetate. Lead has more than one oxidation state, so bring it back. Lead 2 acetate. This is a trihydrate. Mercury. And this is nitrate. Mercury has more than one oxidation state. Crisscross it back. You say mercury 2, dihydrate. This is chromium, carbonate, and chromium is more than one oxidation state. Since there's nothing to crisscross back, carbonate's a -2, so chromium has to be a +2. And this is a nonahydrate. Running out of room. Scandium, and this is permanganate. Scandium does not, scandium 3. Oh, that's wrong in my answer key, so no to that. Yeah, so scandium does not have Roman numerals, and then that is a heptahydrate. Hepta. Zinc sulfide. Zinc does not have Roman numerals, so zinc sulfide, hexahydrate. Aluminum does not need Roman numerals, chromate, tetrahydrate. This is cesium, oxalate. Cesium does not need Roman numerals. This is a monohydrate. Notice there's only a 1, water. Cobalt does need Roman numerals. Cobalt, Roman numeral 2, because you crisscross that back. Cyanide, pentahydrate. And this is copper. And this does not have a Roman numeral. Well, it does have a Roman numeral, but perchlorate is a -1, which means copper has to be a +1. Perchlorate, and that's an octahydrate. Okay, so then the last one, name them: sodium, bromide, strontium, iodide, these are binaries, aluminum, sorry, this is super messy, nitrate, that's a polyatomic, calcium oxide, lithium permanganate, iron hydroxide, but iron is more than one positive oxidation state, so it must be iron 3. This is, I'm like not in sync anymore, so ammonium phosphate. This is scandium carbonate, and scandium does not need Roman numerals. Magnesium nitrite, hexahydrate, and copper does need it. Roman numeral 2. What was that? Thiocyanate? I forgot that one. I gotta look that one up. Thiocyanate. Yeah. Thiocyanate, and this is a tetrahydrate. Write the following formulas. Okay, so you got to remember your diatomics. Iodine is I2, HOFBRINCL. Barium is a +2, carbonate is -2, so it's BaCO3. Potassium +3, no, that's wrong, goodness. Potassium is +1, phosphide -3, K3P. Manganese +3, bromide -1, MnBr3. Tungsten is not diatomic, so it's W. Chromium is a +2, sulfide -2, so CRS. Technetium, Te+4, dichromate. Dichromate is Cr2O7 -2. So this is mean because it's Te2 Cr2O7 taken 4 times. It actually can be brought down to a 1:2 ratio. Silver permanganate is AgMnO4. Silver is a +1. This is a -1, so we'll just get rid of those. Gold 1 perchlorate. So Au is +1. Perchlorate is ClO4 -1, so that takes care of that. Nothing to crisscross. A heptahydrate is 7H2O. Beryllium is +2. Oxalate is C2O4 -2. O4 minus 2. So that gets rid of that. Neutral. And a non-hydrate is 9. Okay. So if you have any questions, let me know. That's a lot, and some of my handwriting is very messy. Please reach out if you need help. Thank you.